Now let's start looking at some graphs of polynomial functions. And we're going to start by working with just polynomial functions of one term. They're called power functions. And so in the first few examples here, I want to look at graphs of f of x equals x squared, f of x equals x to the fourth, and f of x equals x to the sixth. We're already familiar with f of x equals x squared, so I just drew a quick sketch of that parabola. But something that we haven't said yet is we haven't introduced, we are going to introduce here notation for what's called the end behavior of the graph. This f of x equals x squared graph keeps rising up higher and higher as we move to the right. You know, x could be 10, 100, 1,000, and we would just get y values that are larger and larger. The way we represent this symbolically is we write the following. We write as x approaches infinity. X arrow infinity is what we write down. And that just means as we move further and further to the right, then comma, then we write f of x arrow infinity. F of x approaches infinity. Here f of x refers to the y values of points. So when the x values get very large, the y values on the graph also get very large, and the graph takes off, rising up to the right. We also talk about end behavior in the negative direction. So we can write as x approaches minus infinity. Now we're talking about this portion of the graph. So we're saying as x becomes more and more negative, what happens to the y values? Well, for a x squared graph, the y values get very large in a positive way. So we write f of x approaches infinity, f of x arrow infinity, which we read as f of x approaches infinity. And that's because the y values get very large, whether we go in a positive direction or a negative direction. Okay, so let's look at another example, f of x equals x to the fourth. And I went ahead and calculated some of these values ahead of time. And maybe I'll start down here at the bottom. When x is 3, we want 3 to the fourth. That's 3 times 3 times 3 times 3 is 81. Same as 9 times 9. 2 to the fourth, 2 times 2 times 2 times 2 is 16. 1 to the fourth is 1. 0 to the fourth is 0. Negative 1 to the fourth, now because I'm raising a negative to an even power, that will be a positive, have a positive value, 1. Negative 2 to the fourth, also positive, will be the same as positive 2 to the fourth, 16. And negative 3 to the fourth will end up being positive, that's 81. So now let's go ahead and draw a graph. I'm going to make each square worth 1 on the x-axis. So 1, 2, 3, negative 1, 2, 3. But for the y-axis now, I want to fit some of these points. So I think what I'm going to do is I'm going to go 10, 20, 30, 40, 50, 60, 70, 80. So I change my scale on the y so that I can include fit some of these y values of coordinates. Now let's go ahead and plot these points. Negative 3, positive 81. It's going to be way the heck up there. Negative 2, 16, negative 2, 16. Now that's 10, 15. I just have to approximate its location about like so. Negative 1, 1. Now negative 1 is here on the x-axis, but the y-coordinate for 1 is, on this scale, is very, very close to the x-axis. So I just have to put that point close to the x-axis. Close to the x-axis I can get it. 0, 0, 1, 1, similar situation. 2, 16 will be symmetric to that point above negative 2. 3, 81 will be symmetric to my point at negative 3. And I think you can see that I'm getting kind of a U-shaped graph again. It's very similar in shape to x squared, but of course the scale is different here, and it's actually it's a little bit more flattened out at around the origin. You don't have to be that sensitive to that, but there is a difference in shape where it's kind of flatter. It also goes rising up more steeply to the right, and also as x approaches negative infinity. End behavior. So rising up to the right as x approaches infinity, f of x approaches infinity. End behavior when x is negative. As x approaches minus infinity, f of x approaches infinity. So that f of x equals x to the fourth and f of x equals x squared, they have the same end behavior. Now I'm going to look at another even power of x, and you might even be able to guess where this is going, but let's go ahead and plot some points. Now I'm graphing x to the 6th. I'll start at the bottom here again. 3 to the 6th power. I used a calculator. Help me with that. 729. 2 to the 6th power. You should be able to do that in your head. 2 times 2 times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64. 1 to the 6th power is 1, 0 to the 6th is 0. Negative 1 to the 6th is positive 1. Again, negative 2 to the 6th. Now, I'm taking an even power of a negative number, so again, I'm going to get a positive result, right? This will be positive 64. Negative 3 to the 6th will be positive 729. So I can label my x-axis the same way as before. But now, if I want to squeeze in some of these values, I need to get all the way up to 729. So maybe I'll go 200, 400, 600, 800. So kind of a dramatic change in scale here, right, for the y-axis. And now let's go ahead and plot negative 3, 729. So here's 7, 729, just approximate. Negative 264. Negative 264, it doesn't even go to the top of the first square because that's 100, so I got to be already there. Of course, negative 1, 1 would barely show up. It would, it wouldn't even show up above the x-axis. It's so close. 0, 0, 1, 1, 264, and 3, 729. And here I get sort of a U shape again. But even a little bit more flattened out and rising up a little bit more dramatically, sharply, as x approaches infinity and minus infinity. Main point for you guys to get down is the graph is U-shaped and the end behavior. As x approaches infinity, f of x, the y values approach infinity. As x gets large, the y values get large. The graph rises up. As x approaches minus infinity, so we draw the arrow going that way even though we're imagining going to the left. As x approaches minus infinity, the graph rises up again. So f of x approaches infinity. And so same end behavior as those x to the fourth, x squared. In fact, all even powers of x are going to have this basic U, like a U shape to their graph, and they're going to have the same end behavior as these examples we've looked at. So in the next video, we'll look at odd powers of x.